Welcome to our first of 3 webinars in an urban critical zone data jams webinar series. The idea behind our webinars are to support educators who are interested in either doing a data jam competition with their students, which is something that they could participate regionally all along the fall zone, possibly make prize money for their students. The other option is, of course, to just do an urban critical zone data jam with your students in your classroom, self-contained, no deadlines, no Angie lurking over your shoulder telling you that I need your reports. Either way, this webinar series is designed to support teachers who are interested in implementing some form of the critical zone data jam with their students. My name is Angie Hood. I'm an education program leader working from the Carey Institute of Ecosystem Studies out of Baltimore, Maryland. I work under Alan Berkowitz, who is the head of the education in the Carey Institute of Ecosystem Studies. That's a picture of him right there. That is the entire Urban Critical Zone education and outreach team, just Alan and myself. There we go. Tonight we have 90 minutes of programming for you. We are going to do welcomes where we're at right now. We'll go briefly over the objectives of tonight's webinar. We will look into definition of data literacy and think about why it's important. We actually are lucky enough to have a couple of our urban critical zone scientists with us this evening who are going to introduce the data sets that are at the core of this iteration of the urban critical zone data jam. We will have an opportunity to work with the critical zone data jam data sets ourselves, introduce a platform called CODAP that you can use with your students. And then we'll talk about kind of what's next for the Urban Critical Zone Data Jam, including our next webinar series and what the topics will be. So our goals are kind of twofold. We have the overarching goal of the Urban Critical Zone Data Jam, kind of answering the question, why? Why are we data jamming? The idea is, of course, to promote data literacy with high school students. That is in alignment with NGSS, of course, but that's also just in an alignment with being a critical thinking human person living on this planet. So promoting data literacy using real local, in the case of urban critical zone, fall zone data sets collected by our researchers. Tonight in particular, what we want to do is introduce you, the participants and viewers, to the data sets themselves. As I said, we do have a few researchers and scientists with us this evening to give us very brief introductions to the data sets. And then, of course, you'll have an opportunity to work with the data sets a little bit, and I'll show you where to find them on our website. The other goal for tonight, other objective for tonight, is just to help you feel a little bit more comfortable using this platform CODAP that I'll introduce with your students, and that way you can support them and they use the CODAP platform and our urban critical zone data sets. So what is data literacy? I think it's that one of those buzzwords that's out there, and a lot of times we hear it and we think, yeah, data literacy, that's great, it's really important, but then we can't quite put our finger on, well, what is that? So there's many different nuanced definitions of data literacy that are out there, but they all pretty much have the same underlying message. So I've chosen to use the NCES data literacy definition, which is essentially just the practice of examining and understanding data in order to draw conclusions and communicate those conclusions and make decisions. Excuse me, a data literate individual, you can read data, you can work with the data, you can communicate information found within that data, you can reason with the data, and you can critique data-based arguments. All of these, again, are highlighted not only in the NGSS, but other local science standards throughout the country, and I'm sure the world. So throughout our webinar series, we will help you support your students in all 5 of these major kind of themes of data literacy. At the end of the day, why bother focusing on data literacy? Why do we do it? Not just because it's in the standards, but because in order to create solutions to all of the world's problems, right? Real world problems are out there. The best way to solve them and to come up with solutions that are effective is to start by being data literate, right? I was just in a webinar, a different webinar, maybe last week, and we were talking about the data standards and the cross-cutting concepts. And somebody that was leading the webinar just said this really simple statement, and it was that data is truth, right? So here's some data. Here's what the world is telling us. If we can make sense of that, then we can do something with that, and we can come up with these solutions to these problems that are facing us. We're now ready to hear from our scientists and researchers that we've invited to give us introductions to the data sets. So we'll first hear from Dr. Laura Torin, and then Dr. Peter Grafman, and then finally we have a recorded video from Dr. Joel Moore, who unfortunately was not able to join us this evening. So Laura, you are up first if you want to go ahead and let us know what we should know about anions in the Pennypack data set.
So I'm going to be talking about the Pennypack anion data set. And we collect the data in the Pennypack, and I have this picture of my student collecting a sample. And when you look at it, you think, oh, that doesn't look like an urban stream. But let's take a look at the land use. This is where he was collecting his data. And in Philadelphia, they've developed a park system along the creek, but it is surrounded by a very, very urban setting. So don't be fooled by the pictures of the stream, because you don't have a lot of park there. You've mostly got urbanization. And with urbanization comes a number of stresses. The runoff can have temperatures that upset critters living in the stream. The runoff has a very high volume and it causes bank erosion. We've been living with a lot of salt lately, and if you got that crunch, crunch, crunch feel under your feet, eventually that is going to get caught up in rain, and then the rain puts it into the streams. So we've got a lot of salt right now in our streams. And then in the Pennypack and in some other urban streams, we have wastewater treatment plants, and they dump nutrients into the stream. And I think if we were to kind of summarize all these things together, we've got a very large volume of stormwater going into the streams because of all that pavement, and that in itself is a stressor. So what are we doing in Pennypack Creek? This project is sampling along the creek, and this is a map of the creek. I put the geologic provinces here, and I love the colors because it shows you the creek's kind of divided into quarters, an upper portion, two middle portions that have slightly different geology, and then a lower portion, which is supposed to have a different geology, but a lot of this green stuff has eroded away and we're back down to the pink. So these are somewhat younger sediments. These are pretty old sediments, and these are really old. They've all been metamorphosed. If any of the people are from the Philadelphia area, there's a lot of Wissahickon schist in the pink area. We sample at 2 USGS gauges every 2 weeks. And they're on either side of this fall line that Joel will talk about and Angela mentioned briefly. So in our biweekly sampling, we're catching 2 of these geologic areas. But and I forgot I was going to show this slide. So one of the things I noticed in the biweekly sampling was that the downstream site always had more variability than the upstream site. And they're not that far apart. And I just kind of wondered why. And when I zoomed in on a map, there's what looks like a tiny stream in between my 2 sample points. But this is actually a buried stream. And that's a lot of what happens in Philadelphia. Things got buried when we built up. And this buried stream actually collects from a 2.5 square mile area, lots and lots and lots of storm water. So I went in and sampled that stream for a year, and sure enough, it created this variability. It looks almost, it has the same variability as my downstream point. So just things that come in, and that kind of motivated us to do what we call this synoptic sampling. So what we do with synoptic sampling is, instead of just sampling these 2 points, we sample all the way up and down the stream And we try to do it all in one, really half a day. We do it in about 1 kilometer intervals, which took 4 teams of people. So we split up our segments, and the teams each got their assignments. So it's a lot of crawling down into the stream because of the incised banks, collecting our sample and hurry up to the next stop. And then we bring all these samples back to the lab, and we have to divide them into subsamples that Joel and other people analyze. So we filter for about 2 or 3 hours. It's a very long day. And this is the data set that I'm sharing with you. It's a map of the chloride concentrations that we mapped during one of these synoptics. So you can see how frequently we sampled here. And the shading gives you a sense of how much chloride was in there. So we were kind of dilute up in the headwaters. It got a little bit high, and then it gradually diluted back down again. And then we got a couple samples downstream of that storm drain that get a little bit heavier in salt again. So I put all this data into a GIS file and will share it with you and the students. And then I created just a 5-minute video that you can share with your students that tells people how to navigate around this file, so they can use GIS without actually having to create the file and do the GIS programming. But it gives them a little familiarity. A lot of my students have told me that when they interview for jobs, if they can show that they know how to put data on maps, employers really like it. So I like the idea of introducing your students to maps early on in their career in a pretty simple way. You can use CODAP to create a map like this. I've given you the XY coordinates, but the underlying map that GIS gives you is, I think that's what's kind of exciting for the students. They can see where their samples are located. I also share an Excel file with you. This is what you could, this is something I plotted in Excel, but this will give you the data that you can put into CODAP. And in my plot, I used colors to match those geologic regions. I plot my data on a Y-axis, and I included a couple arrows where I thought some interesting things were going on, like where's the wastewater treatment plant, and where's that sandy run that I told you about that is a tiny stream with a big impact. The files that Angela will share with you, she may have changed the names. I didn't ask you if you did, but these were the original names that I gave it. But the files you should look for is a doc file that has questions for your students and a link to that GIS map. There's a 5-minute video that I recorded to learn how to use the GIS map. I provided a PowerPoint that has an answer key. So I ask a bunch of questions in that doc file and I answer them here. And what I do is I encourage the students to use GIS and to use a little bit of algebra to understand, like, this wastewater treatment plant, how much stuff did it put into the stream? So it gives them a chance to use their math. There's the Excel file, and then of course I have this GIS page that I'm sharing with you. So that's what you should get from me to do the Pennypack sampling exercise. And I'm happy to answer questions. Angela has my contact information, and it is on the slide here. So thank you.
Thank you so much, Laura. I appreciate you taking some time out today to give us a quick intro. All right. Well, I mean, what further introduction do we need? Dr. Peter Grothman, if you'd like to go ahead and tell us all about greenhouse gases and dead run.
Okay, so I have my data. I'm a big data jam fan, and I'm very just delighted that you all can use these data sets. I think it's a great exercise for students, and I'm just delighted that we're doing a data jam with these data. I'm going to talk about some dissolved gases in streams, and I'm going to make the case that they provide some insight into urban watershed function. I'm a professor at the City University of New York, and my co-conspirators in this are Claire Welty and Mary McWilliams, who are at the University of Maryland, Baltimore County. I'm going to talk, and again, I'm hoping to talk for just 5 minutes, a little bit about what do we measure. Mostly I'm going to talk about the roots of this work, like the broader context for this work, a little bit about the methods, and then a little bit about what the data look like. So when we talk about dissolved gases, we're talking about carbon dioxide, nitrous oxide, and methane, which are greenhouse gases. We also measure argon nitrogen ratios and oxygen. Oxygen is a good indicator of just a fundamental component of stream health, and the argon nitrogen is indicative of nitrogen cycling activity. So we measure these gases because we're interested in greenhouse gases, which we're concerned about. We're interested in nitrogen cycling and activity and pollution in urban streams. We're interested in indicators of overall biological activity. That's again oxygen and carbon dioxide, and then we're also particularly interested in anaerobic biological activity, which is important for nitrogen cycling and pollution. So that's what we measure. We measure these gases. We learned a long time ago in ecosystem ecology that if we sample water, we can learn something about the watershed that produce that water. So watersheds are areas of land and that drain to a particular point. And so we sample that stream that's draining. We can learn something about the ecosystems by analyzing the quality and the quantity of the water in the streams. And I'm going to fix my pointer here. And it is very analogous to urinalysis. So if you go to a physician, the physician will take a sample of urine, will measure the chemistry of the urine to infer something about the health of the system, which in this case is the patient. And in the watershed approach, we sample streams, we analyze the chemistry of those streams, and we learn something about the function of the watershed ecosystem, the system that we're studying. And it's very useful, for disturbance. So if patients have disease that shows up in the chemistry of the urine, the same if we disturb our watersheds, we learn about it'll be reflected in the chemistry of the streams. So we analyze disturbances and analyze responses. We use those responses as a platform for asking questions about, well, why did we get that response, and what are the internal dynamics that lead to those responses? So I wanted to just spend a little time talking about that, and this is also true for Laura's data, and also for the data that Joel's going to do. All these are rooted in the watershed approach, and it's this idea that we can learn about ecosystems by analyzing stream water quantity and quality. And again, it's analogous to urinalysis. And this approach originated in forested watersheds. So these are some forested watersheds in New Hampshire. These are about 100 acres in size. This is a picture taken in 1985. And you can see these are watersheds. All the rain that falls within this area drains to this point. We have watersheds that have been treated in different ways. And we've been sampling these streams down at the bottom of these watersheds since 1965, and longer in some cases, to learn about the function of these patients or of these watersheds. So again, this is a long tradition of sampling water coming out of watersheds and learning about what the watershed's doing. And in this case, so in Laura's case, she's measuring salt and she's measuring a bunch of ions. Joel is also measuring a bunch of ions. We're measuring these gases, greenhouse gases, and gases that tell us something about the function of the system. Angie can give you the details on our watershed, this Dead Run watershed. It's an urban watershed. We have 3 different sites within the Dead Run watershed. We've collected samples every 2 weeks for 3 years. We measure dissolved oxygen with a probe. We measure these gases that are in the water, right? So we got to get the gases out of the water. So we put the water sample in a bottle with a headspace, an airspace, and we shake it. And the gases in the water come into equilibrium with the headspace, and then we sample the headspace and analyze that by gas chromatography. And this is a little bit of fun chemistry called Henry's Law. And the Henry's Law said basically there is an equilibrium of these gas concentrations between the liquid and the gas phase, as long as you shake them and as long as they're in equilibrium. And so you can predict different gases have different solubilities, but if I can measure the concentration of the gas in the headspace, I can calculate the concentration that's dissolved in the liquid. And so this is a little chemistry that underlies this. And then a little bit about how do these data look. So this is carbon dioxide data. Carbon dioxide data is just a good old indicator of biological activity. We started sampling in the winter, and so the concentration was cold in the winter, concentrations were low. They went up in the spring and the summer. Down in the fall, down through the winter, up through the next spring and the fall. And then again, we have 3 years. We have these very strong seasonal patterns where it's low in the winter, high in the summer, as we would expect. And we also see interesting differences amongst our sites. The blue lines are one of our particular subsites, and it's consistently higher than the others. So this is what the data look like, and I think it's going to be fun data to fool with because, again, there's seasonal patterns and there's differences between sites. And the other examples, I'll show you methane concentrations, which is natural gas. It's a very potent greenhouse gas. And here, it's even more dynamic. So you can see it's high in the summer than in the winter, but there's really big differences between the years. So concentrations were super high in our second year of study. They were really quite high in this third year, much lower in the first year. So again, there's a bunch of mysteries in there where people can look at the data and then get at some of those mysteries. So that's our data set, and that's all I had about that.
Excellent. Thank you, Peter. So I like to just kind of talk about, right, we're here thinking about where these data sets fit into our critical zone data jam process and planning, and it's those mysteries, right? We don't know why. Maybe we do. Maybe we ask the students to do that. And those are the kinds of stories that we hope, right, when we're looking at the greenhouse gas data and we see those weird annual patterns and we're looking at the pennypack data and, Laura mentioned like, oh, why do I have these weird, what's in between these two measurement sites that's causing this to happen? And we look a little closer and we see Sandy Run. So those are, speaking to the educators here who will be working with our students, those are the kinds of, things that we want our kids to look at and say, I got to figure out what's going on there. I want to dig deeper and I want to know what's going on. That is the foundation, the basis of a data literate person. I want to look at that and say, what is happening? So that's
the magic of data jam.
Yes.
And again, I drank that punch. Laura drank that punch a long time ago. But we hope to me, I like data jam because I think students can look at that and if they like it, then they can have a lot of fun with it. And the other thing is we're training all our environmental science students now in data, which is a useful career skill. So if they decide environmental science is boring, they can then go work for Amazon or some other data firm and have and I think lots of our disciplines are doing that, whether it's psychology or history or environmental science. We're giving students data skills that are useful job skills.
Right. Universally useful. And I think that's the crux of data literacy. And I know when I was a student, as a science student, it was about the science and, data was just a thing that you did because it was part of your requirement. And I feel like now that emphasis is much more kind of pointed on the literacy skills and the critical thinking skills and why is that happening? About it. Okay. Third and final data set, the stream chemistry data set is going to be introduced by Dr. Joel Moore via a previously recorded video for us this evening. He is also going to do a little bit of an intro.
Good evening. I'm Joel Moore. I'm a geochemist and critical zone scientist at Towson University in Maryland, just north of Baltimore. Sorry I can't join you tonight, but I wanted to give you a quick introduction to the data sets from the urban critical zone that you'll be working with. So the Urban Critical Zone Cluster is a group of scientists from across many institutions, mostly in the Mid-Atlantic, that's led by Claire Welty, who's our lead principal investigator or PI at University of Maryland, Baltimore County. I'm the deputy director, and then we have lots of participants, other principal investigators from other institutions. Starting here with slide showing some sampling from across our critical zone cluster, some graduate students and staff in the left picture where we were drilling for rock and saprolite weathered material samples in the left picture. The right picture is Samantha Voles, who helped collect water samples and lots of other things from University of Maryland, College Park, and then Laura Turan from Temple University working with a local high school class in the lower right. So first, what is the urban critical zone? What is the critical zone more generally? So critical zone is the region from the top of the tree canopy to the depth of moving groundwater. So it includes organisms, soil, water, and rock. It's where all of those interact and shape the Earth's surface, and it's critical for clean water, for productive soil and crops, and for atmospheric chemistry. So thinking about how atmosphere, biosphere, hydrosphere, water, right, of course, and lithosphere, rocks and geology interact and shape each other through Earth's history, as well as in the current moment. So these sorts of processes can take place across minutes, decades, and millennia and eons, and can occur across a variety of scales, from a core that one digs or cores into soils and weathered material up to a whole hill slope, an entire watershed, or an entire landscape. So in most places, study of the critical zone has not
really included much of the human element. And so in the urban critical zone, our goal is to really think about taking that same sort of critical zone thinking and focus on places where most of humans live across the globe. More than half of humanity lives in urban areas, and that will be up to about 66% by the middle of the 21st century. So here's a diagram that we put together for the urban critical zone, where things that affect the chemistry of streams, of soils, etc., include roads, de-icers like road salt, fertilizer, concrete, sewage, atmospheric deposition coming from cars, from power plants, etc. And that falls on a landscape that's shaped by millennia and eons of geological processes of bedrock, etc. And so in our approach to the urban critical zone, we're focusing in on particularly the interactions between the hydrosphere, water, and rock. And we're focusing on both the human components that are mostly minutes to decades and can affect hill slopes and watersheds, and trying to compare those to what happens across geological scales. So how do we sample the critical zone? One of the things we do is we collect water samples, and that will be much of what you're working with. So this is Mary McWilliams, who's at University of Maryland, Baltimore County, doing water sampling and installing equipment to measure water chemistry in real time using sensors like you see on the right. We've also collected soil and sediment samples. We won't be working with any of that data, but that is part of what we're working on and studying and trying to understand the urban critical zone. And so we have 5 sites that are at the core of our urban critical zone cluster. You'll be working with data from 3 of those, from Pennypack Creek in Philadelphia, the Gwynns Falls, particularly Dead Run, which is part of the Gwynns Falls in the Baltimore area, and then the northwest branch of the Anacostia, which is north of DC and Maryland. The 2 more southern watersheds, Difficult Run in northern Virginia, and Swift Creek near Raleigh, North Carolina, are data where the U.S. Geological Survey is collecting those data, so we haven't included those here. But the data you'll be using has been collected every 2 weeks in Philadelphia, Baltimore, D.C., and then all of it has been sent to me at Towson, and we've been analyzing that data and reported out results from our lab here. So hopefully you'll enjoy working with the data and start to understand some of what's happening with urban critical zone processes. And then one piece of data that might be interesting is, of course, the human component includes development. So this is data put together by Dan Bain from our cluster at University of Pittsburgh, where we looked at the number of structures per square kilometer, and the 3 sites to the left, the red, the orange, and the purple, are the 3 sites you'll be working with stream data from. You'll see that those are developed earlier and more intensely. They have more buildings per square kilometer than the 2 watersheds to the south, one in Virginia, the Difficult Run, and one in North Carolina. So you'll be dealing, again, just with one aspect of our project, the stream chemistry. There are many other aspects that didn't cover talk about today, including trace gases, sediments, geophysics, and cores from hill slopes. Good luck, and if you have questions about the data or anything else, certainly feel free to ask for my contact information and talk to me. Thanks. Bye.
All right. So Those were our three researchers. Dr. Laura Torn introduced the anions in the Pennypack data set through one of her lessons that she has created for her students. Dr. Peter Groffman introduced our greenhouse gases in dead run data set, and Dr. Joel Moore introduced our stream chemistry across the fall zone, as well as a little bit of an insight into what goes on behind the scenes collecting the critical zone data. So let's get to the data sets. We have officially launched our Urban Critical Zone Data Jam website. To get to the data sets, you must first get to the website. To make it easy for educators and students alike, I do have a bit.ly link that makes it short and sweet. It's bit.ly/UCZ Data Jam. Otherwise, another pretty easy way to get to the Urban Critical Zone Data Jam is just to literally type it. You can see I've been typing it a lot in your search bar. And that will bring up, and I don't know why I put it in a new tab, the Urban Critical Zone Data Jam competition website. That is the Cary Institute of Ecosystem Studies. That is my home base. And that will take you to our website. Again, you could have gotten there with the bit.ly link as well. So once you are at the Urban Critical Zone Data Jam competition website, that is a mouthful, you are going to look for a sidebar that looks like this. And within that sidebar, you'll find UCZ datasets. The dataset subpage will take you through. So if we're scrolling through our competition page, here's our sidebar. When we click on our datasets, we have a lot of information that precedes the actual dataset links. These tips are just to kind of help you think about what type of tool or platform you want to use with your students. We're going to talk a little bit about a couple of them in just a minute, but we give you three options essentially. One of them is kind of on your own, just using the Google Sheets, and then using Excel, and then finally this CODAP. Anything that you see hyperlinked in blue on the website is a hyperlink, and it should open up to that resource. If there's any issue ever trying to access a resource that should be linked, feel free to reach out. And then way down here at the bottom, we have our three current data sets. Anions in the Pennypack, greenhouse gases in dead run, and stream chemistry across the fall zone. So again, you go to our website, sidebar, look for UCZ datasets, and then these are the datasets. I will click on a couple of those for you during this webinar, but just as a quick introduction to what these datasets include, they all have some brief introduction to both the project and that specific dataset. Once we get into the actual data sets, which are shared with you as view-only Google Sheet files, you'll find multiple pages within that Google Sheet workbook. You will find a metadata page, which includes information like the parameters, locations, things like that. It does vary by data set. You'll find the data itself, and you'll also find maps of each of the watersheds that are being studied, including satellite maps from the Google Earth project we have for one of our data lessons, land cover maps, and USGS watershed basin maps. So let's stop talking about it and take a look at it. So again, I'm down here at the bottom. Oh, I forgot to click on my data sets. UCZ data sets. Down here at the bottom, click on whichever data set you want. Anions and the Pennypack is the first one I picked. And you'll see the thumbnail here that we saw from Dr. Laura Torren. You can see that forested area surrounded by those urban developments. Here is the introduction to the project. Here is a brief introduction to the data set itself, and then we click the blue button to take us to that page. Now, because I'm the owner of this data set, you'll see that mine is not view only, but if you click on that data set, you will see that there's a view only copy presented to you. Here is our background information page sheet within the workbook. So that metadata, again, they vary by data set, but you can scroll down and see there's a lot of information. The data itself, and finally, those maps. So the different data sets will include different resources that are included in the pages, the sheets within that workbook. It depends on the data set itself, but you will always have at least those features. Ooh, too far. So what we want to make sure that we're doing once we're accessing the data sets through our website, through the Urban Critical Zone Data Jam website, is again, because you only have a view only option, you'll want to make your own copy. This is something that we have included here. So we kind of walk you through how you can get to these and how you make your own copy. It's pretty straightforward. Just file and make a copy. You can name it whatever you'd like. You can select where you want that to live, and then you have your own editable copy of this data set. There's a couple of different reasons why you might want your own editable copy of the data set. One of them we're going to talk about in just a moment when we talk about our CODAP analysis tool. So that is where to find the data and how to make a copy so you have your very own copy of data. In just a moment, we are going to go ahead and take a look at the data itself. Again, the goal of tonight's webinar is to get us from the Urban Critical Zone Data Jam website to those data sets, and then getting comfortable with CODAP. So in our next webinar, we are going to spend a little bit more time in kind of talking about how to choose which data visualization model, graphs, charts, things like that, is the best for your selected data set. So that's webinar number 2. Basically, we have this data. Now what do we do with it? For tonight, we really just want to make sure that you're comfortable using a new platform, CODAP, which we think is a really great opportunity for students to kind of get in at the ground level for data visualization. So if you're interested, webinar number 2, we'll talk a little bit more about this data visualization and graph choice chart. So next webinar. So when we are opening up our very own, so I have this copy of anions in the penny pack. This is my copy. I made it from the Urban Critical Zone Data Jam datasets webpage. When we are in this Google Sheet, we have a couple of options. We can just work with the data in the Google Sheet if that's what we would like to do. So Google Sheets and Excel both offer options to make your own charts with your data, and that's totally fine. If you want to, within Google Sheets, make your own chart, you will first click on Insert, and then select Chart, and then select your chart type. And Google Sheets and Excel also have many different chart options. I can't even count them all. I myself am not particularly adept at Google Sheets, chart making, or Excel, which is actually what led me to find CODAP in the first place. But again, just to remind us, if we wanted to stick in Google Sheets and look at charts that are available within here, we would select whatever data we wanted to graph. We would select Insert, Chart, and then we can customize our chart style. Oops, hold on, went too far. We can select our chart style from this first drop down in the setup menu. Again, what data tool you choose to use with your students all comes down to what your students are comfortable with and what you think will work best for your student population. You know your students more than we do, so we want you to make the best choice for your students. What we want to do tonight is introduce this newer platform called CODAP. It is a, go back here. It is a product of the Concord Consortium. So what I'm going to do is I will, using one of our data sets, walk you through some of the basics of CODAP, including importing your data, so getting the data into CODAP, creating a graph, and then where to find help with CODAP. After we do a couple of the basics here, I will pause the video essentially and let our participants take some time to mess around with CODAP and one of our Urban Critical Zone data sets themselves. But without further ado, let's go ahead and take a look at how we can use this platform as a very kind of non-threatening, intuitive, easy to use resource for students really of any age. So the first thing we want to do here is open our CODAP website. So for right now, I'm just going to go ahead and walk you through the basic steps. So you can just type CODAP into your search bar. It is the Common Online Data Analysis Platform. Click on that and launch CODAP. Now, this is the first screen you're always going to see, and you have a couple of options. So I'm just here to kind of walk you through. I have a brand new data set. It's my first time working with CODAP. What do I do? How do I get the data into this platform? We have user manuals that we've created, and CODAP has a huge resource library for helping you do higher level things, including statistical analysis, different kinds of access to data and things like that. But tonight is just the basics. So I'm going to create a new document because I have this sheet full of data that I want to make sure that I bring over to this platform. So I'm going to create a new document. Now, there are multiple ways that you can get your data into this document. So again, I'm working with my copy. I can get rid of this chart. And what I want to do is I want to get this data into this platform. The first option that you can use with your students, which I think is relatively straightforward, is to just drag and drop. Now, this is where the first kind of issue of making your own copy comes in handy, because when you use the drag and drop method, which I'm going to show you here, so you click on this icon in your Google search bar and you hold it over your CODAP tab, and that will switch your tabs, and then you can just drop it. Now, it's going to give me an error. So this is your first error message. And the reason I'm getting an error message is because I don't have permission. So I get out of here, I go back to my sheet, and I make sure I share it, anyone with the link. Now, same thing, I go to this icon in my URL bar, I grab that, I pull it back to my CODAP tab, it switches it over, and I drop it. Here's the second reason that you want your own copy of your data set. You'll notice that even though I was on the data page when I dragged that, what they're giving me is the information about the data. So whenever you drag and drop from a Google Sheet into CODAP, it's actually going to only drop the first sheet in your workbook. So what you want to do is, in your copy, drag the data tab to be the very first page in your workbook. Now, I'm going to go ahead and delete this table, go to tables and trash that table. Yes. Now that I have my data as my first tab, I can grab this, hold it over that, and drop it. Now we have our data. There's other ways that you can drop data into CODAP, and we do have them listed here. So if you want to use CODAP, you will need to save your data as a CSV file. And then from that, you can either drag and drop directly from your downloads. So let me show you what that looks like. And go ahead and share my screen a little bit differently here. Desktop. So what I'm going to do is, from my data set, I will hit File, Download. I need to download this as a .csv. And then from my downloads, I can pull this over here and drop it. Now, because I have a nearly identical data set in here, it's telling me that I probably already have this information, and I can choose one of these options. I'm going to create a new data set so you can see that that makes a whole new table, but it's identical. The other option that you have for creating data sets within CODAP is to come up here. Where did my laser pointer go? So come up here to the drop down, click Import Data, and then Local File. You can again drop or select a local file from your computer. What you use depends on your students, the devices they're using, what restrictions or firewalls your school district has. So there's a lot of workaround within CODAP to get that data into that platform. Again, CODAP itself has a huge library of resources. One of those resources is working with teachers who have Google Classroom. You can assign these as assignments in Google Classroom, and then you don't have to worry about dragging or dropping any of this. So there's a lot of different ways that you can kind of tailor your CODAP experience to match you where you are with your students. All right. So I've taught you how to get your data into CODAP. Now what do I do with it? Well, I'm going to go ahead and minimize some of these data tables. They're all the same. I don't need all of them. So we've got our data, and now we want to make a graph. And so all we need to do here is come up here to where it says graph, click that. Because I have more than one table in my CODAP platform, it's not automatically populating that. But what I could do is I could delete some of those tables. Or if I didn't want to delete my tables, all I need to do is work in the one table that I want to visualize the data in. So to get any kind of data into your graph, you can simply drag and drop. So let's say I want in this anions data set to have an idea of how far away I am from the headwaters of the Pennypack stream. And so I just grabbed this from this table and I pulled it over here and let go of it in my graph. And I have this. This isn't really telling me too much about the data. I see that I have kilometers downstream of my axis, but there's not a whole lot of information there. So I want to go ahead and try to pull the y-axis over. So I'll grab another one of our parameters up here and drop it. And then we start to see some of those patterns form. The students can drag and drop multiple different parameters into the graph at once. You can remove them or add them by clicking. There's many different ways to manipulate this data. And that's one of the best parts about CODAP is that it's really intuitive and there's really no mistakes that you can make. If you do something and you didn't want to do it, you can undo it up here. So again, I definitely recommend spending some time working in the CODAP. We're going to have a little bit of time in just a moment working with the CODAP tutorials that they offer. Just getting your hands dirty and pulling the data in and messing around with it to see what you can see. Now, Dr. Torin in her introduction did mention that you can graph using CODAP. Graph. You can plot sites and CODAP using the map similar to GIS if you have the latitude, longitude data, which we happen to have. Excuse me. So we do have latitude, longitude data here. Longitude, latitude, as long as your table headings are listed as such as your parameters are listed as longitude and latitude, you can come up here and click map and it will automatically populate that data. Excuse me. Again, we just see orange dots here. That doesn't really tell us too much, but what we could do, is similar to what Dr. Torin showed us in her presentation. We can grab this chloride parameter and drop it right in the middle of the map. And that will give us a legend, or it will have, give me this. Excuse me. It should give us a legend to show us the data sets, and I'm not quite sure why it's not. Let's get rid of this. There it is. Easy to troubleshoot. All you have to do is click some buttons and you'll see exactly what you're looking for. So you can see that there is a higher concentration in this area. Now, this does offer a satellite view. It's not, or it's a terrain view. It's not as detailed as what we see in ArcGIS, but this gives your students an opportunity to not only see the map view, but also to have that graphical representation. You can also create legends in your graphs as well by doing something, similar. So I just want to get this guy over here. I could pull that same parameter, that chloride, which I have in my y-axis, into the middle of the graph and drop it, and it does that legend for me as well. So we see those higher concentrations of chloride ions at around between, I don't know, that looks like about 7 and 15 miles downstream from the headwaters. So that is a very, very quick introduction into how to get your data into your CODAP platform, how to create a graph, and in this case, how to create a map. So again, synoptic, we take all of the samples within one afternoon, very, very close together. So it's kind of like a snapshot in time. So the map data set is really only applicable for those synoptic datas. If you are looking for help with CODAP, like I said, CODAP has a wonderful resource library. So this is just a workbook that I found on their website, Common Online Data Analysis Platform Startup Guide. I also offer a how-to handbook that I put together as well for our data jammers with a lot of visuals. Click here, look at this, do this. And really, between CODAP and our handbook here, there's a lot of information that you have at your fingertips. And even our Getting Started with CODAP workbook does offer links that take you directly to the CODAP website. So if there's something that we're not offering in our handbook, we have given you the avenue to get you back to the CODAP website. The CODAP website URL is relatively straightforward. You can also just search CODAP. When you are in CODAP, and I'm just going to create a new document here, you'll always start out with this screen. And so what we recommend is with your first foray into CODAP, go ahead and click open the document and work through the first 2 Getting Started with CODAP tutorials. They have you do everything that I just showed, but also you get to do the steps. And I think that that's definitely more valuable in your learning how to use CODAP. And I've used this with students as well, and I think it helps them too. So you can give them tutorials until you're blue in the face, but until they do it themselves and until you do it yourself, it really just makes a big difference. So getting started with CODAP 1 and 2, those are the best way to get started with CODAP, aptly named. And then we would ask you to import one of the UCZ data sets into your own CODAP workspace to find trends or patterns in your data using CODAP. All right, so before we wrap up here for the evening, I just want to do a little bit of a comparison. We briefly touched on the data analysis and visualization tools that Google Sheets has available. And then we did a very quick introduction and brief period of CODAP investigation using the data sets. And so I do want to talk a little bit about why we are even thinking about CODAP. And it really just kind of comes down to that user-friendly ability to look at data. And I know that as an adult human person who was tasked with looking at some of the data sets that we have available, it was really daunting. And I was getting really frustrated. My data wouldn't work out correctly. I couldn't get it to graph this way. I felt like there was huge barriers. And that's, me Googling, trying to figure out how to do this in Google Sheets and how to do that in Google Sheets. And it was a really daunting kind of frustrating experience. And that's an adult trying to do this. And so I know that my students in my classrooms struggled as well. So if they didn't have very simple data sets to graph, then a lot of times they would give up. And so with CODAP, really the idea is to kind of lower that barrier to entry to data literacy. And I think it offers kind of this user-friendly opportunity for kids to just get their toes wet with putting stuff on axes, right? It's digital. It allows you to immediately undo options. So if oh, I didn't mean to put that on the axis, then you can just undo it, right? And so it gives them the opportunity to really explore without too much direction or instruction, just to get a feel for how data can be represented. And so when we're kind of talking about these samples, so this is a different data set that was our greenhouse gas and dead run data set. And the data set itself is huge, right? We've got the 3 trace gases that Dr. Grofman introduced, date, and then the sites. So we have the 3 different subwatersheds in dead run. And in order to graph this using Google Sheets, you have to do quite a bit of heavy editing. And so I made my copy, and you'll see that I had to separate my dead run into different gas sheets in order to graph these. When I did do that work, I was able to create really beautiful graphs, just like Dr. Grofman showed us. But the problem is that a lot of work went into that in order to get to that point. Had I just selected the original data set and tried to make a chart out of that, it's a really messy process. However, with our CODAP, it becomes a much less daunting experience, because once we drop that data in there, there's a lot of really great ways. And so I'm going to go through this really quickly. You can see it automatically populated because I just have the one table. And so maybe I just want to look at NO2. So you know what I'm going to do? I'm going to put date on the x-axis, and I'm going to put concentration on the y-axis, and I'm going to go ahead and put my gas as the key. And so it shows me all of the gases, and I can see that there's a lot of fluctuation in the CO2. It doesn't look like there's anything going on down here in the NO2. I don't see CH4 at all. So in CODAP, what I can do is if I just wanted to look at NO2, I could select that and then hide all of the other data sets. So hide unselected cases. And then I can see just the NO2. But now how do I make it so I can see the sites? Well, I can do that by pulling the site over and dropping it in the middle of the graph to create that legend. So again, we have that data. It's the same data as we saw in my NO2 graph, but it took me 30 seconds to do that. It took me probably, and that might be a me problem, but it took me probably 20 minutes from start to finish to get this graph after my raw data set. And so the idea with this CODAP platform is that reduces that barrier to entry for students. And so they don't have to feel like they're a computer scientist just to get a graph made. And if something's wrong with the graph, they can just change an axis or remove a label. So that's really what CODAP is all about, is kind of opening more doors for students, lowering that frustration too. So, oh, I forgot to do my animation. So if you're watching this at home, and you're looking to navigate to the CODAP tutorials, I have that breadcrumbs there for you. And this is just what we were talking about. At the end of the day, you know your students. If you have, AP environmental science students who are also taking computer science courses, maybe Google Sheets is the more sophisticated method for them to graph this data. Maybe if you are working with sixth graders who are struggling to know which x-axis or y-axis they should be labeling, CODAP is going to help you lower that barrier again. And it's not just for sixth graders who struggle to label X and Y axes, it's for adults too. CODAP really opened up a lot of data analysis doors for myself. So give it a try, but ultimately, you know your kids, and you'll choose which method is best for your students. So we are in the wrap up phase. Appreciate you sticking through with us to the end. This is what we've got coming up next. Next week, next Thursday, same time, 6 o'clock Eastern Daylight Time. I believe daylight savings happens in between then and now. Oh, I don't like the spring one. I prefer the fall one. We have webinar number 2, which is, we've got the data, we've got a visualization. Now, what do we do with it? And so we'll kind of continue this conversation, really digging into the interpretation and the analysis of that data. These slides are going to be posted on our website, and when you see them, you will see a hyperlink. Here is our Critical Zone Data Jam webinar series poster number 2. I will link this as well so everybody can see what we're going to be doing. Gives you a little sample of the CODAP data analysis and then the registration form. So you can also find this, I'm doing a lot of clicking, in our Urban Critical Zone Data Jam website.
What is the date for the next webinar?
Next Thursday, March 13th, and then the 3rd is Thursday, March 20th. So they're every Thursday, 3 Thursdays in a row.
Okay.
And then in the UCZ advisor resources and our website, I have links to the webinar poster, flyer, advertisements, whatever you want to call them. So here's the second one. These will be replaced with the recordings as they happen. So we'll post the 3rd one. But again, the dates are next Thursday, March 13th, 6 p.m. And then the following Thursday, March 20th at 6 p.m. Registration forms, again, are here. And this whole flyer is located in the website, linked there. The 3rd and final webinar in our series, which is March 20th, is that effective communication piece of that data story. So part of our data jam is to communicate what you learn, those aha, like, I wonder what that's happening for, why. So connecting it to the learning that the students are doing or have done to write that more traditional science report, but also the whole fun and games of the data jam is to create that creative piece. And so we want a lot of teachers request support in how do I help my students be creative, but also stay true to the story that's in the data. And so that'll be the third webinar, is to help your students take what they've analyzed and turn it into something creative. If you're interested in competing in the Urban Critical Zone Data Jam competition, registration is due April 4th. It's just a little bit less than a month from now, and the projects will be due May 6th. Of course, if you are not interested in participating in the competition this time, you can always do a data jam with your students as an end of unit or end of term project. We still have the webinars to support teachers doing that. Some of the perks with respect to the data jam competition is your students are entered to win prizes based on their projects through the judging and the rubrics. And you do have deadlines that you have to meet, obviously the registration and the submission deadline. But again, students have an opportunity to compete, and kids love the opportunity to maybe win some money. And then, the other hand, if you choose to just do a data jam with your students, you don't have that kind of strict deadline. You still have the webinars and the website for support. And with that, we come to the end of our programming, and I've left some time for some questions and comments and concerns if there are any. But before I stop the recording here, I just want to say thank you to our live participants and to Doctors Torin Groffman and Moore, who were so kind to share their expertise with us this evening. If you have any questions about Data Jam competition, about data jam, not competition, just with your students, or about any of the other urban critical zone education resources that we have available, my contact is here. I'm happy to answer any questions or point you in the right direction. So thank you and good night.
Thank you so much.
Thank you, Pauline. Have a wonderful evening. Thank you so much for